So now I am live, hopefully. So now it yes. Okay, so I didn't realize that there's a button I need to press to start the stream. Anyway, so I tried to get started. Yes, so but at least chat worked and I have it integrated so I can see what you're chatting. So let's get restarted. So I need to find where I can find my presenter console. There we are. And presenter console goes a bit annoying, unfortunately. So let's put the live chat somewhere. We breaking stuff. So now let's go. So yeah, so what are the trick for the labs? We're going to use the Virtual P201. I hope you have some idea. You've already had a look at that. We'll have a look at it from Teams. There's also Piazza to help you and the discussion channel in Teams. Yes, the slides will be on Brightspace and the video will also be provided as a recording after the fact, split up into parts. So yeah, it seems my computer is still not as powerful as I'd like it to be, let's say it that way. So then we have Teams, so we can have a look at how Teams works. So I need to switch to Teams. Yes, that presenter console is really annoying, unfortunately. So anyway, so we have the application of programming principles channel. You can see there's some people having discussions. Where is it going? I thought I was broadcasting, but obviously I wasn't. So hopefully that works now. So we have the Virtual P201. So Virtual P201 has a general tab where we put announcements. There's a student guide here. We also have the individual support request channel. So we have people monitoring that. So if you get stuck with your assignment, you can actually have a look at that. There is also here another tab where you can read the student guide. So that's Teams. And then the assignment. So the assignment is basically the same as it was, except that we will obviously not have in-lab demos. We need to finalize this, but we probably will just be working on your submissions and your journals, obviously. So then week 1. So last week we looked at what kind of data you have, or 2 weeks ago in Python, how does logic work in Python, and how do loops work. And you hopefully have been doing the exercise last week and this week as well to get started with that. And if you have any questions, please let me know and we can see what we can do about that. So what tools do we have for the tools we have for PyCharm are for Python are PyCharm. That's probably the best tool to use. You can download it from JetBrains. I would say by far the easiest way of doing it is using the toolbox. I'm not sure if it already includes Python, but you can install Python by hand if you need to. And so that is PyCharm. We'll have a look at how that works later when we have the debugging section. Just today we'll have two parts. One part covers professionalism, functions, exceptions, and part 2 will be documentation, classes, and debugging. So there is 2 other elements of content in these slide sets that I will provide you as slides, but we will not really cover because you do not actually need them, and we need to make sure that we know where Python, so that you are ready for the assignment. For a link to download PyCharm, I think we put some information online already, but I'll have a look, and it should be available. But you can always go to jetbrains.com/download. I put it in the chat. So that's where you can get it. I think last week's slide set also had a link to it. So, professionalism. So again, like last week I said, you might want to have a look at this guide. This is about how to write code that is easily understandable by your readers. Yes, and you can get indeed the professional version. You do need to apply for a license. Yes, help each other, that's a very good idea. So the style guide is basically Python enhancement proposal number 8, and you can have a look at it from the unit directory from Brightspace, hopefully. And there's also the idea about doc strings. That's basically built-in documentation. So if you use your Python, you want to know how do I use this function or class or whatever correctly, you can actually ask for the documentation. It's quite cool. And of course you can get that you can write that yourself as well. So what does a documentation string look like? In Python, it is basically you start your function with these 3 double quotes in the beginning, then a proper sentence or multiple proper sentences if it's not a single line, and then 3 quotes to end it. That's actually a multi-line string, so you can actually put it in multiple lines. The convention there is to actually have the first line, then have an empty line, and then you put other markup with other meanings. For example, you can document your parameters as well as your return values, and you add text after those, obviously. So, and then you can add in additional information after the parameters. That's the convention. There is not really any good reason not to follow this convention. So that is the docstring. So functions. So you have been using no functions up till now. You've been using them, you haven't been writing them. So you've been doing a little bit of this logic stuff, etc. But at some point, a file is kind of a too big thing to organize your code. So what you want to do is organize your code in a concise way. So that's what functions are about. Okay, question. Do we need Brightspace journal logs? Yes, we do. So in these functions, why do we have them? We want to be able to reuse our code. You can, in particular, in the same class, you can often be doing the same thing again and again where just a value changes. Looking back at your math, where you have these fx equals x plus 2 or x squared plus x plus 5, you probably remember those kind of functions. In computing, we have functions that can do that and can do more. So functions can change variables, they can hold variables, etc. So that are functions. So we can reuse our code. We can actually also use it to manage complexity. Because if we have a function with a certain functionality, what we can then do is to basically make sure that this function does so that how to perform the function of the function is only discussed kind of in the body of the function. But when you want to use it, you do not need to think about how to perform that function. And another really important part of functions is that you can give names to functionality. So rather than having a block that says, okay, this is how I'm going to use this function, you can give it a name, and it makes the rest of your code much more readable. And the function block, it's clear what it's for, so you even have that to be quite easy to understand. So what does this look like? So this looks like basically hello world. In this particular case looks like this. So we have a hello and we print. So we have a function. We start out with def for define. Then we have the name of the function, and then we have the parentheses that give us the list of parameters. In this case, there are no parameters, so it's an empty list. And then we have inside this as a function body. Like in our logic, we have the indentation, and our hello world is, so we print hello in this function. So and then we call this function by just giving the name of the function and the actual parameters we want to use. In this case, there are none, so we don't give parameters. If we did hello hello, we would do the same thing twice. Of course, print is also a function. So we have seen print, we have seen range. Range just gives us a number of numbers. The len function as well is a function that gives us the length of anything that is kind of list-like. So how do you define your own function then in detail? So we start with the def keyword. Then we have our name. We have any parameter that we need and a colon at the end. Then you put your documentation string after that, and yes, it works if you don't put a documentation string. And you can, so the pound sign or the hash, whatever you want to call it, that's comments. So you can do that, and then you have as many lines as you need to perform the task, and then you can have a return keyword that gives you a result for your function. So if you have a function with a result, you can then say print name whatever parameter you have, and then the print function is passed the result of calling your function. So there is one thing that we need to think about is the keyword none. That is a kind of a return type for a function that does not return anything. So how does this work? We have a function hello here that doesn't return anything. So if we then have, so what we can do is then we can look, is the return of hello none, is the return type, then we just print just as expected, because hello does not return anything. There's no return keyword. And a good thing to remember is that defining a function just puts that name, makes that name available to use later. It does not call your function. You can call a function 0 or many times. So yes, the pound is a comment. So it doesn't do anything. So we have a variable here that we can assign the result of the name, as I said. And the style guide says that you should put 2 lines between a function and the rest, just to give a little bit more clarity. So one of the things that you might want to do in cases is like, okay, I need to get a lot of user input. You might say, okay, yeah, every time you get that, I'm just going to do that then and there. But it's much easier to define a function such as getNumber, where we can say, okay, I just have a function that gets me numbers between a minimum and a maximum. And we implement that by first starting with an input where we ask for a number from our reader. So you should be able to see my mouse now. So we ask for the input here, and then we convert that input into an int. And then we say, okay, as long as the value is not between the minimum and the maximum, we update the answer with a try again input. So we basically loop until we have an answer that's within the range. And yes, this does not check that the input is actually a number. So it could crash for that, but that's at this point not necessary. It's just an example. But that's the idea about functions. You can encapsulate this needed behavior in a place where you can really benefit from it. So, and then you can do something like, okay, for a month, get a number between 1 and 12. For a day, get a number between 1 and 31. And that 31 does not have to be a literal. If you want to do this even better, you can say, okay, after I got the month, I'm going to check for the month how many days that month had, and then I'm going to pass that amount of months into the getNumber for days so that it becomes dynamic depending on what month that the user gave. So on February we would have 28 or 29 if it's a leap year like this year. So these numbers do not have to be static, they can be variables. So, and then you can use the templates to put in that thing in a print statement. So then there is an important thing to think about with function, that is scope. So if we have this function greetUser, we basically, so what it does, it puts a name into from an input, and then you can print that out and stuff like that. What is important is that name variable that is in greetUser only exists in that function. Not only does it exist in that function, it only exists in that particular function call. Or every time you call that function, it creates a new variable for that particular call of the function with the name where you can store that, and it disappears afterwards. So if you call greetUser inside greetUser, you would have 2 copies of the name variable. So as that slide shows, when we use the print in the bottom, that name doesn't actually exist. So then, modules. So we can organize our code into modules. So what you often do is you create modules where you put a lot of functions inside that have a common functionality. And what you can then do is you can import that module in any Python program to get to reuse stuff. So when that works like on this slide, we have the import keyword, and then we have the file name without the py where we get it from, and then you can use it. You can also import slightly different way to get it straight without having to use the .name bit. So then file IO I will be skipping because we don't actually need it today. Instead, I'll go next to the part about exceptions. So what are exceptions? Exceptions are a common way of error handling. I think you've seen them in Java as well. JavaScript has it. So hopefully it should not be too hard for you to understand what things are. Anyway, so the idea of exceptions is that you basically have a way of returning an error state out of bounds. So in particular thing like, for example, if we have that age function, what happens if someone writes out the name 21 in text? Well, the int function can't handle that. The int function will say, okay, I can't handle this. You have to do it in a different way. So instead, what the int function does here is it will actually throw an exception. So in this case, it would be a value error. So how do you handle these exceptions then? So these exceptions are going to be thrown around, and they are basically, so you handle them by wrapping the code that may throw an exception into a try except block. So instead of just trying to ignore it, you can, and then your whole program crashes. We don't want that. We want to handle the error in a good way. And what we want to do is to basically, what happens is, in this case, for this particular example, we have a try keyword, we get the input, and then we divide that. And if you input a shoe size of size 0, this will throw an exception because we can't do division by 0. The except case works that way. So that's basically how exceptions work. So your code will continue at the except block, and then after the try except block, you can continue executing your code. What happens if you have multiple handlers or multiple exceptions you might want to handle? Because we also still had that value error. So in this particular case, the except value error says print, okay, sorry, you have to enter numbers. So you can handle different errors. You need to know what the type is, and the best way of figuring that out is by going to the documentation of the functions that you're using, and that documentation will tell you what the types of errors are that are available. So in some cases, you might also want to do something, okay, if there's no exception, or anyway at the end. So the else keyword allows you to do things that if there's no exception, and finally basically executes code at the end when there is no need. So yeah, so print in Python 3 is a function. In Python 2 it wasn't. So yes, it changed. So if there's some code example that had no parentheses, then that was wrong for Python 3. I will have a look later on the slides, and if there's an error, I'll fix that. There's also there's sloppy indentation here as well. It will work, but it's sloppy. Probably part of the reformatting of the code. Anyway, so how do you handle exceptions in a good way? Because again, coding is about not only doing something, but doing the right thing and doing it in the right way. So you do not want to just say, okay, I'm going to swallow the exceptions. Instead, what you want to do is handle the exception if that is an appropriate way. So when you're reading numbers and you get an exception that there's a value error, you say, okay, I didn't get a value, so you might assign it like -1 or something like that, and then, okay, we loop again because it's not in the range. Or you give a different error message and you have a Boolean where you want to do this. So we skip over, so sometimes you also can get things like if it's not correct data, you can redo it again, etc. But if you can't, if you can't handle an exception, what you need to do is you re-raise it or you propagate the error, and not just swallow it and say, okay, yeah, I'll pretend nothing happens. That is a very good way of getting code that is unstable. So, for example, so one of the things you can think about here is like this particular loop. Does this actually finish? If we, that depends on whether or not this desk banging before dog picture happens. Yes. As a little bit of context, Gail had lots of dog pictures in the slide sets. I'm not that way inclined, so there's no dog pictures in my slides. But yes, hopefully Gail is happy in Portsmouth. So, although she's probably still at home at the moment and not commuting to Portsmouth. No doggos, no doggos. Sorry. So, some example on the doc strings still. For example, this is a way you could do this. So this is the first full sentence. So a function Fahrenheit that takes Celsius as a parameter. As you can see, there's no types needing to be provided. This is it makes it easy to program. You can have functions that basically even are polymorphic based on the type of input. You can do some really interesting stuff with that. JavaScript programs tend to really overuse that. But it also means you do not get the compiler to help you check that the type you get is actually a number. Like for this particular function, we would want Celsius to actually be a number. That can be an integer or a floating point number, but it has to be a number. So the this takes a parameter, so we can document what the parameter means, so temperature in Celsius, and they return whatever the temperature is. So you can use this like this. So Python has one feature that's quite cool. I think, no, I don't think you have used it yet. That is named parameters. So when do you use that? Why do you have that? So you don't have to use it. If you do this function without the name, it works correctly. It's also, but why do you want to use it? Because it makes it easier for the reader of your code to know what it means. This is particularly important if you have functions that take a number of parameters. And it also really helps if you have default parameters where some of them don't actually need to be passed at all. In that case, you can just give the parameters that don't need to be default. But if you have a number of, like passing 4 booleans into a function, true, true, false, true as a parameter set is not very meaningful. It's not very clear what it means. But at that point, providing the name for your parameter makes it much easier. But yes, I am going to record this. I am recording this lecture and I'm going to upload it at the end. So, like I said, you can do default parameter values. So in this case, the default parameter value would be the degree 100 degrees Celsius. And then you can call it without that. This particular example doesn't make too much sense in a programming perspective, but it is a good example of how this works. But that is basically part one. We have the idea of classes. So, by the way, if you think we need to have a break, let me know. Otherwise, I will just continue, and then I'll finish up with a little bit of PyCharm live demo. Hopefully that works. So what are classes? So in Java you have seen classes, obviously, because you cannot do anything in Java without classes. And that sometimes is a bit confusing. And kind of when you have a function that, like in Python we had this function, say Fahrenheit, this is what we call a free function. It's a function that's not defined in the context of a class. Java, you technically can't do that, but what you can do is almost the closest to that, which is define them as a static. So a static method in a class is one that does not need a class instance, an object, to actually be called. And in Python we don't need that because we have free functions. So when we have, for example, this is a class hello. So in this particular class we're trying to just put some code here. So how does this work? We define a function, and this function is called sayIt, and this has this self parameter. This self parameter is based on the idea that if we have an object and have a function in the object, we are passing along the object, so that the function knows the object it's being called on. And this happens transparently, but you need to have that object, that parameter in the function. So in Java, that's the this object. In Python, the convention is to call it self, and you actually need to declare it, name it as a parameter, rather than have that all happen transparently as happens in Java. But yes, underwater, Java just passes the object as the first parameter, so that it is accessible to the function implementation. So in this particular case we can create a greeter by calling the constructor, so the name of the class with construction parameters. In this case there's no explicit constructor, so we just get a default that doesn't do anything, and then we can call the function sayIt on that greeter. Obviously it's not actually using the self object, so it doesn't actually have any functionality where you'd say, okay, this is where I want the class for, unless you have different classes that you might want to pass into a function and then have different implementations of sayIt. So basically what a class does, it allows you to bundle data and functionality together, and that's kind of where the strength of classes is. So you can define attributes for a class to hold the state, and then you can combine things. So like if you have a coordinate, you can have an x and a y value together. Of course you can also use a tuple in Python, but sometimes it's good to define your own class, especially if something is a little bit more complex, or if you want to make your code easier to read and therefore easier to maintain and to work with. And then you can have methods that provide functionality based upon that. So it's a template. It's so kind of when we have a class, we can basically, a class is kind of a recipe how to make objects that all have the same functionality, like a cookie with a stamp, and the stamp you cut the cookies. The cookies all work the same, they look the same, but obviously each cookie can only be eaten once. But you can have multiple cookies that look the same. So data works a little bit like a dictionary, and functionality is a function. So an example of what this looks like might be the best thing. So here we have a constructor. We have a special function, and Python has a lot of implementation through convention. So there are a lot of functions that have this underscore underscore name underscore underscore name, where that has special meanings. So look at the Python documentation or book if that's helpful for you. So in this particular case, the constructor for hello, so this initializes it, takes of course the self parameter and a parameter called message with the default message hello world. And then you can then just assign on the self object a variable. So by naming the variable and giving the value, it automatically gets created for you. And then we assign that the message parameter. And then we can use that message parameter in the sayMessage method to print the message parameter out of the self. So it's quite a lot like Java, except that we explicitly always need to use self here rather than that having to be implicit. Like in Java, you can leave out the this dot bit. And of course, this is how you can use that. And if you have hello that has a different message, then that works. So in an adjusted parameter, we can have hello in French, and that works the same way. Except now we have this parameter and the message is now bonjour instead of hello world. So attributes are just accessed through the .message bit, like I said, and we can change that. We can actually change that also outside of our object. That's an interesting thing. So we don't really want to do it this way where we just access the attribute directly. This is possible. Python does not have this visibility thing that Java has, but it's not really great. We also don't really want to go through this whole set underscore message thing bit. It's verbose. It's a lot of typing, but worse, it is also have the bit, so it makes it harder to read what's going on. It puts a layer between your intent and your code. So instead, what you want to do is to have something that looks like greeter.message equals salut. And the way you do that is with something called properties. So Python now has the property system based upon an annotation at property that you define on a function message, and then it becomes visible as a property. So in this case, the property message does not require the parentheses, and this is a getter. What does it do? It returns the underscore message. So the underscore there is just convention. It is, we as Python community have decided that attributes start with an underscore. That's all. It is not required the same way that the underscores on the init are required because it looks for that. It expects to find a method with that name. That's the only reason it has underscores. So now we have looked at how to read a message. How do we write a message? So we can have the setter, and this has an interesting annotation where we have the setter of that particular property. So we annotate it that way. So we have the getter, and then we kind of link a setter to that property. And that works by having a function like this. So it takes the object, again, we always need the object, and we need to have as parameter the new message. And then we check, is that actually a message that's not none, because we don't set it to an empty value. Then we set the message field to the new message parameter. Yes. So yeah, no super chats, huh? No super chats. No super chats needed. I do get paid for this. I'm much more lucky than those people that have had their jobs cancelled. Maybe they were working in a bar or something like that. Not particularly nice, even though the government is supporting it. Yeah, yeah, yes, yes, yes. No, I'm not gonna sell you any VPNs either. So inheritance. So sometimes you have a number of classes that kind of work together about stuff. And that's about inheritance. So you can have a class that kind of takes the functionality of another class. And that is what we use inheritance. So we start out with, okay, we import the class hello from the file hello class.py. That's where we start with. And then we have the class, and we can define a class name hello, where we put in parentheses the parent. And now we can have a constructor that takes two parameters, message and prompt. And because hello, we just seen that, takes one parameter, which is in the constructor, which is the message. So we use this special, not really a function called super. And then we create the super object, and then we call the init function on that with the message. And then obviously we can set the prompt in addition to that. And we can then create the personalized function that allows basically that allows asking the user for their name, and then you can hopefully change later on the greetings based upon that name. So when you use this, you can say, okay, what's your name? And then you can say that, and then personalize will ask for this thing, but when we print that, it doesn't do anything at this point yet. Or let me have a quick look. No, so it sets the message or sets the name already with that. So in a personalize, it will say, it will print the message and then adds the name. So yes, no, it does work correctly. Again, sometimes reading code is confusing. We'll look at the debugging and how we can do this much easier. So yes, this add thing is when an annotation is kind of to change the way that Python understands what your function is about. So yes, so let me know if there's any particular questions. I'd be happy to do that. Of course, I'm trying to filter out any limitations based upon chat that's going on. So there's also something that you can use in imports. So if you have a module that is runnable, you can also, so if you want to have use a runnable program also as a module, you can use basically a main function, and then in your actual module code you say, okay, if the name of this module is __ main, so it's not actually imported but it's run directly as code, then we call this main function. So this is how you can actually have a module that uses main. So 69, that's not bad for attendance. I didn't have to see that. So so yes, we can do a Q&A later on the assignment, and we might switch to Teams for that. I think I might do that, or maybe announce that, because YouTube is not particularly good for Q&As, but we can do Teams, and that works really well. That's why we have a team. Then, another part, APIs. So we can skip this bit and put more time into actual live coding, because I think that would be very useful for you. Because basically the APIs are, so what are APIs? I'll do a very quick brief part of this and then we'll go on to the rest. I think that's best. So an API is just the interface that is provided for programmers to program something. Because it's not only a library, so when you program, you don't only use a language, you very much also use libraries to use that. And in many ways, the programming experience is defined by the libraries available. Yes, I don't have Discord, but Teams works really well, and I can record the Q&A with it, and it can have up to 300 people, so we don't need Discord. But so we'll do Teams for now. Anyway, so the Java library is an example of an API. Online services have an API. One of the things that you'll be doing for the assignment is to create using Flask, and we'll come back next week how to use that with some demos. It's actually quite easy once you get the hang of it, to provide for the JavaScript that you've been creating on the front end part in the beginning of the unit. And a Python module also provides an API. It's just the functions provided. So Java has the standard library, and you have the REST API. So Tim provided you a sample implementation that just doesn't do anything. It just gets you those things. So REST APIs are basically using HTTP directly, and they're very easy to use. The hardest bit is handling errors, because many things can go wrong with web APIs, including lost connections and stuff like that, that you all need to handle some way. Anyway, so REST APIs, I think it's already been covered that you want to get resources, or if you just want to read the state. Post is when you want to update it. You send some data, some parameters to a resource, and that resource then can update itself. Put can be used to create a resource, and delete to remove it. So in many cases people use post and get only. Put and delete are much less common, but they were originally already included in HTTP, because it is known that if you have all these 4 primitives, or also called the CRUD primitives, then you can do everything you need. You see the same primitives in databases, for example, where we have the select for getting data, update for updating things, insert for creating it, and delete to delete. These are the data manipulation constructs in SQL. So HTTP has the same. So I talked about what it does, and you can, depending on what your API endpoint gives, you can get JSON as a result. So particular something like this, you know what JSON looks like. It's like the data definition part of JavaScript, except that you don't want to parse it as JavaScript directly, because that's a security issue. Then we have some sample APIs that I'm just going to skip, and we're going to debugging. And basically the debugging, there's some slides, but I will skip the slides. I will leave the slides in the slide set, and I'll go to do some live debugging instead. So let me quickly go to PyCharm, and there you have PyCharm. So hopefully, I thought we'd had PyCharm. Yes, you do have PyCharm. Yes. I do play Minecraft actually, sometimes. I haven't done it for months though, but I do play Minecraft. It's cool, but only modded. Anyway, so data. So this is an example implementation of your exercise that you're still doing. So I will not be providing you these files yet, but you can have a quick look. So this is basically just a very simple bit of code. And one of the things that I find that many people have a problem. Okay, so I will put it on full screen. Hopefully that works better. I see if I can, I'll set it to some bigger font. And there's settings. Okay, it's loading. Let me have a quick look what is causing all the... So or it might be an appearance font. That sounds like a good place. Yes. So it doesn't the greatest font. Okay, yes. It's the full one defined here. So let's put it on 16 or maybe even 20. So hopefully this makes your life a little bit better. Oh. Let me do this slightly different because I actually have my full window open, but it's a window capture that I'm using, so the settings window is not visible to you. So hopefully this size is good. Okay, we're going to this size, and then you can see this. So it becomes a little bit big. There is presentation mode, but it makes it hard to actually get out of. But yes, there is a presentation mode. So presentation mode. So you could do that, but I'm not too good in the shortcuts yet to be able to do that properly. Anyway, so we have this sample implementation. So one of the challenges many students have with their coding is like, what happens? It becomes kind of really hard to get a grasp upon. And there's kind of two ways that you can do this. One of the ways you can do this is you actually have this Python console. So if you want to say, okay, I want to try what some code does. So what is the result of taking 70? So I'm not sure where this description is from. Why is this doing this? Okay, PyCharm seems to have crashed for me. I'll restart it. I think that's probably the best way to go. And it should be coming up fairly quickly now. There we are. So yes, the tips. You say I would advise everyone to try to keep this up for a while because there are so many features in this tool that help you. Yeah, yes, Notepad. Yes, Notepad is if you're masochistic. These tools really have a lot of power. They take a lot of memory, that's certainly. So it does like a beefy computer, but you don't need that. But they give you a lot of help in making not mass autistic, masochistic. If you like pain. Yeah, no, hardcore programmers use a program called VI. And so you can find, I can show you, there is VI mode for the editor. Okay, it doesn't seem to have it implemented here, but there are, like, you can put your text, your input configuration like it looks like VI. VI is not easy to use. It's an old Unix tool that is a particularly weird editor. Anyway, for this particular code, so you can put in your print, so you can print 8 divided by 3 and get the result. And so you can do some simple math. We also, and there's another way. So this console is really helpful, but there's another way of actually doing this, and that is the debugging. So the easiest way of getting started with the debugging is just press the mouse here in the middle, so next to a number, and then you get this red dot. This red dot means that there's a breakpoint there. And when you then, okay, so it needs, okay. I haven't configured it to run yet, so I should be able to just say with this file run. Okay, it's sorry, it's a bit sluggish. So we can debug the file. So if we do the debugger rather than the run, it goes into a special mode where you can basically see what's going on. And okay, yes, so we can have this Cython extension. I'm not going to do this right now. I would need to restart and stuff like that. You might want to do that yourself. Like I say, I haven't really checked that. So now we can see the blue line here where we actually have the code paused. So we're now on line 7 of the module data.py. We don't have any variable, so there's some special variables available. So if you wanted to know what's the name, we can see here that underscore main underscore underscore. So these are 2 underscores, but some fonts don't make it this visible that it's 2. It also has a doc string. So you can see here we had this doc as just a text thing. It has been put into this variable automatically by the loader. Then there's some other information that there's no value. In this case, none is the value. So those are special variables, but we'll find that we can do this. So how do you use the debugger? So we have now stopped at a particular point, but we want to move on. So there's kind of 3 key elements to that. And that is the continue. So you can resume your program. That's the F9 key. Did the audio still work? Okay, yes. Yeah, let me know this thing, because I had my microphone bug out onto me with another lecture because the battery ran out. Not very helpful, but yeah, so let me know if it's a problem. Anyway, so we have the resume program, F9, that just runs the rest of the program. So if we do this, we just get some prints in the console part, and that's it, and we are finished. The program is no longer running. So I'm starting again. I'm just pressing this one. So most of the time you don't want to just do that. What you can do is you can just go to a line number and then press that, and then we run to that cursor. And so now you can see, after we have done that, we now have the horizontal line, which is, I'm quite confident, 15 dashes. At least that's what the code here makes it. So we have the horizontal line. You can then say, okay, actually, I don't want 15 dashes. I actually want it to be having some equal signs in it. So you can change it. We can also see here on the behind the code line that it also displays the variable there, just to make it very easy. So yeah, my face is not visible so that you can see my code better. But my face will come back when we need to. But I think it's more important that you can see what's going on. Particularly the debugger is not sized up, so to speak. Not like the main code. Yes. So that's our variables. So you can see the variables, you can inspect them. And we can see now that we are on this line, print horizontal line. So what thing you can also do, sometimes going to a particular line is good. You can also go to the next line. So there's these functions here. Again, most of the time you don't use these buttons. You use the keyboard buttons. Because what you do a lot is to step next, step next, step next. So step next is F8. So continue is F9. Step next is F8. And F7 is to step into. So if you have a function, if you want to go into a function, you use F7. So in this case, we go to the next line, and then we printed one on the horizontal line. So we can see now in the console that this has been printed, including the equal signs that I've put here. So that is so that's worked. So if we now go to the next line, we print hello world. And when we look at the console, yes, it has been printed. And I think it might even be possible to detach the console or something like that. So I'm not sure. No. Yes, we can put it there. So we can actually see it at the same time. Okay, it should be doing it. Oh, it doesn't. I don't think it wants to do that. Unfortunately, it's not supported. So, and then you can do things like that. I think it might be bugging out a little bit on me here. Oh, it finished somehow. I pressed F9 instead of F8. Yes, so that's a challenge. More interesting is if you do this in a case where you have logic. So, for example, we can go here and we can check the value of integer. So we debug logic. And we get here to the line where we have logic. So we have a number of variables. We can see here what the values are. The integer equals 11. In this case, we say, okay, is this equal to -1? So we can see here that it actually isn't. But sometimes you have expressions that are a little bit hard to understand. So what you can do instead is you can select this, and then you can go to quick evaluate expression. And what that does, it should come up and it will actually quick evaluate expression. Control. It should be able to give you the true value. We can see it here. So, or what you can do, sometimes the quick evaluate is not very clear, you can actually go to the evaluate expression itself. So it copies that expression in there and we can evaluate that. Oh, it is not equal to 1. Maybe if it is equal to 11. And then we can see that. So you can basically put questions to Python here and to make it work. Yes. No, I'm not going for the YouTube play button as yet, but 100 subs would be cool. I made it a business channel, or a brand channel they call. Anyway, so that's how you can do this. So particularly when we have expressions like this, it becomes kind of hard to sometimes see. So we can here see, okay, what's animal? So when we go, just continue until here. That's probably the best way. And then we can see, okay, what does it evaluate to? And we can see it's skipping not to the next line, but the next line that's actually executed. So it is smaller than vulture, because this is just a textual comparison. So this in textual, small letters are later in the textual comparison than capital letters. So anything with a capital letter is smaller. So in this case, it will print animal, etc. So we can see in the console, animal is smaller than, etc. So there's basically what you would be doing. So for loops, it kind of works the same way. So you can, for example, put a loop in here and we have various items. So let's see how this works. So we debug loops in this case. So it automatically creates a configuration for us. So yes, this is KDE on Gentoo Linux actually. So it's not Mint, it's Gentoo, but it's a compile yourself one. It's not a beginner's distribution. So anyway, we are now in the loop. And in this loop, we have different grades. So we can see here in our variables view that we have the grade, that we have 3 different grades. We have pop, dad, and cf, and it also has a length parameter. So it's a dictionary that has those things, and then it kind of underwater maintains this length field. Yes, I have been in the chat a little bit, but I have to pay attention to my lecture. So anyway, so now we are in the loop, and in the loop we can see that we have a key and a value variable that is available that match our grades. So we have pop and 99 in the dictionary, and we have that in our field. So we can then print that. So now our console prints it, pop 99, and we're now back at the loop. The loop goes again, and now we see that we have a new value, key and value, that basically is the next value into the dictionary for dad and 87. Print dad 87 and print again, and then we are at the end of the loop. And that kind of shows you how this works. And it's a very good way of actually putting your code to see what is going on. And especially for those of you that struggle, okay, how does this work? I would advise you, play around with this. Look at what happens. Finding errors in your code by either looking at your code, staring at it, or by putting piles and piles of prints in your code is just really, really hard to do. And it doesn't help you with doing things, okay, what's the value of this expression? And if you have an expression you want to look at all the time, you can even create a watch. So you can create a watch. Say we wanted to see what grades dad was, we can actually see that the grade for that is 87. If it changes, so we can actually go to the evaluate expression tool, and we can be really nasty. We can say grades that equals 42. And if we do this, so this is another way of changing values. It will actually do exactly that, and we can see now in the variables view that this grade has actually changed there. And this is basically very useful if you need to keep track of the value as we go along. So if we do something that is grades Paul, that shouldn't exist, it gives us a key error exception. Paul is not a valid key. So we can see here that it's an exception. Obviously that was something I triggered, so you know what is going on there. So that's how you use a debugger. So, and you can use this, so you can put number of breakpoints in different points. It's a little bit of getting used to, but a breakpoint is basically where do you stop. A cool thing you can also do is put a condition on a breakpoint. So if you make a breakpoint, you can then go and put a condition. So number equals 5. So this will put a breakpoint, and we can see that it's a conditional one because it added a question mark here. So if we now continue, it will run to the part where the number in this particular loop is number 5. And we can see from the console that we did this while else before, and now we're there. We are currently at the total of 64, and we can loop beyond that, and we go again and again. But if we run this again, it will not stop again because we have already passed the number equals 5. And the console says, okay, it found a total of 110. Because we couldn't reach the target, because our numbers were not big enough. Anyway, so that is what you can do with debugger. There's many more features. You can go with more, and the cool one is you can actually also, if you want to do a print line, you can do that with debugger. So you can have a debug point that you don't do a suspend, but then you say, okay, I want to get the number, I want to print the number. Or you can say number equals plus number. And when we run this through a debugger, we have to use a debugger because by the debugger makes your code run a lot slower. But in most cases it doesn't matter. So let's get out of this one because we don't need that. And then we can find that in our console we now have we should have not okay, there I think there is a problem here in my expression. So yeah, so test it out with evaluate expression first. Let's see if we can do this anyway. So we have a breakpoint here, we run it to the breakpoint. We can then go to evaluate expression. Yes, I use the shortcuts because they make my life a lot easier. Okay, evaluate expression doesn't want to come up. Oh, it's different shortcut than I expected. So what we can do is total, so total plus st. I think I think we just use templates. I think that's a better way of going about this. And then we have number dot format, and then we have total comma number. And it even gives completion to kind of help us how to do this correctly. And that's why you want a tool like this. yes, this is a valid expression, so we just select it, copy it, and then we can put that into our evaluate bit, and then we can even stop the suspend, and then when we run this, we can now see from the console that we have all the totals printed. And that didn't change our code, it only changes the evaluation. So that is how you use the debugger. And let's go back to the lecture. And I need to go back to the slides there. Okay, it doesn't. For some reason or other, it refuses to take it. There we are. Oh, it still doesn't work. Let's do it this way. So this works. So exercises. So I will be creating the exercises. I haven't done that yet. We'll be doing it the same way as we've done now, as with checklists. Hopefully that works well. So there'll be a number of exercises in the different topic areas that should help you to get used to this. So yes, attendance, I think that is something we probably throw out of board. Do attend, but recording attendance is a little bit of a tricky thing. So the attendance is there only to help you to do your learning. We can see through Brightspace that you have actually logged on to the system. I think that's where we need to leave it. But attendance is there to encourage you to attend. But yes, live chat works well, but I don't know who is who based upon your YouTube names. And that doesn't matter. So the exercises, so basically the idea is now to practice. So next week you can practice. I will also next week be putting out starting points for how to start the assignment, how to start the backend part of that. In particular, how to actually use Flask to host your web page so that you can integrate everything together. And so that's the lecture for today. What I will be doing now is I will be stopping the live stream and I will be going to Teams to do a Q&A session. So everyone who wants to follow that, come to Teams and I'll set up a meeting in our channel. I'll show you where we are. We'll set up the team. So in Teams, we can do a Q&A. So for application of programming principles, and then we can do a Q&A in there. So I'll create that, but I'll stop the live stream for that. So I start the meeting now, but let's wait a minute because it may not be working 100% correctly. So I'll see you in the team.